Hello. I have some catching up to do. These puzzles should probably be getting harder as well. So I'm gonna stop monologuing. Let's get to it. ASCII. Very impressive. Is this just a... It's just one line? Okay, it's just one line. So... That didn't work. We are asked to compute something, and we're just... This is another one where I don't really know how to explain in more detail than I'm going to literally do this in code. Okay, so we do need to split by comma, but we'll do that. For, what is this, chunk in this, we're going to compute its hash. To do that, or it takes the ASCII code, no, for character in chunk. First, okay, no. Current value, we have a value, 0. We're going to take the ASCII value of the character, increment it, multiply it by 17, and then mod 256. And then we're going to sum all of them. And I'm using a lot of bad variable names, but it's probably fine. Okay, so this is the actual challenge. I think this just reeks of, oh, part 2. There's kind of only one reasonable part for some reason. Okay, so it's actually had just looked like a programming language kind of thing all along, right? All right, so each thing is a step. Sequence of letters followed by either equal sign or dash. Okay. What are we doing? Okay, I'm gonna do parsing as I understand the problem so that I can offload the part of the parsing that I've understood into the code and then stop worrying about it, hopefully. So each thing should have either an equal sign or a dash. Should split into 2 points. Focal length. The right side. What is this? It's a label. Just cut off the last thing here. Okay, so that's the parsing. And the hard part is here. Okay, so we have 256 boxes. Each box has lens slots. There's a lot of lenses. Label of the lens. So each lens has a label. Oh no, we do have to hash. Okay, I see. Hash on the label. The hash. So okay, so this is the hash. And hash is a built-in Python function, so I sort of don't want to call my variable hash, but it's a good chance we won't use that. So still, out of a sort of principle, I guess. So V is our hash, and that is the box, the correct box. Forward in the box. Okay. So each box is an ordered list of, let's even write the type out. What is this list? It's a list of boxes. Each box is a label and a focal length. And front to back. Okay, so it's not that. At this point, we just kind of do it. Okay. I don't think we need to worry too much about performance. Hello. And I'm also thinking a little bit about Python dictionary ordering. I know Python has order dict. I could look it up and figure out how to use it. It might sort of just do the right thing, but I think that working with these lists as dictionaries is cheap enough and I will be more confident in the result or be able to debug what's going on. So we're just going to sort of do it. Cool. So box is V. So we're going to target this box. If there's an equal sign, for lens in, oh, this is kind of interesting because label. So we can't, okay, we won't be, so do I want to do this? I'll do this, it's fine. No, we can't. Type checking. Okay. How sad am I? I will sort of want to mutate an element in this tuple, which means it won't be a true list in a sense. Okay, I think this is served its purpose. We're gonna do that. We're gonna do some hacky things. So we're going to replace the lens replace its focal length with the new focal length. And if we never found a lens, and I'm writing the for else again, but it actually is the simplest way to write this. We're just gonna, we don't even need this anymore. Right, so we're just scanning to find the lens with the same label and setting its focal length. If that doesn't match, if we don't find any match like this, then we're going to add label focal length to the end. And then here we just remove it, right? So is Vim your usual editor? Ask chat. Yeah. I use VS Code at work sort of because of like sort of ecosystem stuff, but yeah, I've been a Vim user for How long has it been? Jeez, I don't know. Like possibly 2 decades. No, that's way too. That's not. It's not. That's a way over. Like 1.5 something. A long time. I'm just going to replace it. Chat asks, do you still use Newlith? Yeah. I love using it as like a calculator and like sort of super quick nerdy scripts. That was always the niche it was primarily geared for. I wanted to not use it. I wanted to use Python for these streams because my guess would it would be more accessible to more people. But honestly, I don't know. Like if lots of people, if I get a lot of feedback that like people really want to watch that instead, I would have done it. Yeah. Where was I? We're just gonna check if the is not the label. Okay. So this is gone. For now we have a power 0 for box. Boxes. I 1 plus the box. What is your okay? So they are. I will put that thing here. Box number plus 1 times 4 lens j lens in enumerate box slot number of the lens j plus 1. We'll also add 1 here. And there's enough finicky stuff here that I'm definitely going to test this. Let's test it out. 2 dot. That did not work. Oh. It's because oh, chat says, I like the idea of Newlith. Not sure if you saw my YouTube video. I made half-baked VS Code Newlith lingers coloring. That's cool. Yeah, I know I have a backlog of YouTube comments to look at. I had a busy week. 5139 is not anywhere close to the... Okay, cool. It's like just totally way off. All right. Let's look at the box. I think actually, wait, am I doing the right input? There's only one input, right? Yeah. Oh, they're way off. Wait, I clearly did not. Am I confused? I thought the hash... On the... Oh, I see. On the label. On the label only. Okay, that makes sense. It's a function if I've ever seen one. We don't need this anymore. That's the wrong variable. $145 seems much better. And done. Okay. It was very slow there. Part of my YouTube comment was wondering if it should be a pull request for the repo or let you release the VS Code extension for it. I'm probably not going to release any VS Code extensions or anything like that. I don't know that much about it. I think you should totally feel free to release it. Okay. Lava. Mirrors, splitters, beam. Okay. So we have to simulate a bunch of things bouncing around in this grid. I'm going to simulate that by having a list of positions and directions represented by deltas. So beam, what is that? So we start at 0, 0, row 0, column 0, and we're going at a column delta of 0, 1. And V is, if anybody hasn't seen, is my helper tuple substitute that makes vectorized addition and like all these math operators. So I can just add two of them together and it will add them component wise, which is super useful for 2D vector addition and that kind of thing. Okay, I am mostly curious. What am I curious by? It is possible for there to be loops. Beams can go in loops if they hit a splitter and then get bounced back into it. You can set up splitters that goes infinite. Just maybe fine. I think we can just do it. Okay. So, so we might have to do like a BFS or something. Or not even that, just what's the best way to do this? Okay. We're going to define a function that takes an input beam and outputs a list of next beams. So, let's see. I'm going to pause. No, log delta equals beam. How does, yes. So we're going to see what cell is, what character is at that location, at the beam we're considering. If it's outside of the grid, that's another helper function. Then this beam doesn't become anything else. Can we match? We can do that. Dot log plus delta delta. This is the part where there's some direction danger, I guess. So there are 4 things and like sort of just a ton of cases. So this is where we want to be really careful because any bugs here are going to be really annoying to figure out. So Which one should we do first? What? I have so many random things here. Reverse, double reverse. Okay, so the mirrors are. I think the mirrors are actually easier. So this will just, if it's like 0, 1, going right a column, it will become 1, 0. And yeah, so it's that. This one, I think it's that. Doing all the cases in my head, this looks good. Okay, I'm gonna do that. Now the splitters, if delta, so if we're going vertically, which means the column component is 0, then we don't do anything. It's just like this. Otherwise, well, let's see. We don't really care which direction we do these in. And I just copy paste this code. That's super dangerous, but we'll just be careful and make sure we understand the configuration here. Yeah, so if it's horizontal, if the row delta is 0, it's horizontal, you keep going. Okay, I think this hopefully this function is good. If we get here, then this character is something surprising. Cool. Shown on empty tiles. Okay. So now what? Okay, what's the latest thing we could do? Energized. Transition every beam every time. That's not, no. So this function takes a beam and returns the next beams right after traveling one. And we're just dumping all those into the set. And we can check if it got bigger. And if so, break, because we're done. And then we have to be careful to submit the number of distinct positions and not the different beams, because beams in our representation that have the same location but different directions are different but count the same. So actually, this is bad because we also include out of bounds beams right now, actually. Which is more convenient to write, so I want to stick with that. So but we just pay the price by doing this filter at the end. And because that bug is kind of scary, I'm going to double check. .46 is good. This is actually noticeably needlessly slow, but it's fine. It's a few seconds. Okay. Oh dear. So I can put a beam on any edge tile. I see. So we do want this to be faster because, I mean, that's fine. And there might be some more speed up than even this because we are exploring the same graph of how beams lead to beams over and over, but it's fine. What am I doing here? This is just a set. What am I writing? So we have 2 generations of, these are the most recently added beams. Don't know why Python still doesn't like me. So basically we have a set of all tiles we've seen like before the last step and all tiles we've seen in the last step. And we only transition the most recently seen beams. Let me make sure this still works, I guess. Wait. We should put this here. And we should check that this still works. It's very fast now, and the answer is the same. So we just need to get the full version. Oh, Chats asks, you mentioned in your blog, are you tired of having 10-line Python scripts? And how different are these scripts in Newlith? Can I post them? This is a good question. I think the way it turned out is like I save these scripts less often because I can sort of bang them out so quickly. I will see what scripts I have lying around. Yeah, I think a lot of the thing is because I just put it in, I put a WebAssembly version on like GitHub and can just type awful code into the text box and run it. I end up not saving the code so very often. Whereas Python, like I kind of have to be, the easiest way to do it is you are at a terminal, you make a Python file, you run it in the terminal. And it's harder to directly write sane Python in the like Python REPL. So then I'm like, okay, I'll make a file. And that's why those files are lying around. And now that I say all this, it's like, it's a strange thing to optimize for, but that's what it was all along. Okay, what are we doing? We are going to, the next step, the final frontier is we have to get all possible first beams, which is like a little bit annoying, honestly. Let's see, starters. I'll write this in 4 lines, just because this is an easier way. So let me first figure out what I want. For every row, we have something traveling right. Yes. For every row, we have something. No, I need to. This is. I will get confused. Okay. Right side looking in. These are not closed. 0 call rows. That's 1 call. And this is going up. No, this is going down, but up on them. It's going. The row count is going up. The row count is going down. One is the sample. Still a little bit slow. Maybe it's. I think it'll be fine. Chat. Oh, nice. I didn't know you had a web version of Newlift. What's the URL? Yes, it's literally like the GitHub GH pages like branch associated with this thing. It just runs in the browser purely as WASM. I should probably, I don't know, is that in the README? It's not really clear. And it's like pretty ugly, but it works. Oh, you can also share code samples like in a URL or something. It's not linked on my base GitHub IO page. I see, that's true. Okay, I will see if I remember to fix that. Thanks for pointing that out. Where are we? 17. Oh, that's cool. We did something. Okay, 17. Have you answered any questions about my Vim theme? My Vim theme is called Jelly Beans. I think I'm meant to get back to a YouTube comment on that. Sorry. Haha. It's, yeah. I think you can just. Do I have anything embarrassing in my Vim RC? Probably not. It's this guy, nanotech jellybeans.vim. I think I spent like a day or two looking at dozens of color schemes at some point, and then I just stuck with. I just like it's good. I enjoy it for no particular reason. I grinned. Yeah. I thought about like the best thing for me to say about work is not that much on a public stream. I'm sorry about that. Yeah. Okay, we have some stuff going on. This is, oh, very interesting. So we have a grid. We are traveling across it to minimize heat loss, but we can't travel in a straight line. Sav? Yes. Did I type that? Yes, that's save as new file. Like, and also switch to editing it. Save the current buffer under the name and set the file name of the current buffer to file. Okay, so, well, I actually think the this is a classic implicit graph problem, I think I might call it, where you have to track not only what location you're at, but also some amount of information about how you got there. And fortunately, you don't need to store too much information. You just need to know which direction you came in and whether you've moved 1, 2, or 3 blocks from there. So let's do it. I think we need another transition function. Oh yeah, Vim has a ton of stuff for multiple files. I mean, like, my favorite thing is if you go to help and look at, where is it? Editing other files? No. Repeating, making a change in many files. I come here all the time to copy this command. This is super cool. You can just run a command on like every file in a directory, or you specify your file however you do it, and then just does stuff. Yeah, 26.3 of the Vim help. All right. So we are again, okay, so we have a word for this. It's a lock, whatever. And a lock consists of a position and a note. This is going to be a little bit run. Okay. So vector int 1 to 3. Actually, it's not even, it could be 0. It's 0 at the end. It's the beginning, but it's usually going to be 3. Okay, so what we're going to do is you can run a command on many files natively in Vim. Sounds, yeah, Vim does like I can just, like, what's the cool command? Do I have cowsave right now? I don't have cowsave. What do I have? Like, you can just, okay, what's good? You can just run your current file through any command you want by, man, I wish there were a better example. If you respond to every shitpost I say, I feel like you're never gonna solve anything. It's fine, we're making pretty good progress. Actually, are we? What day are we on? We're like halfway, I don't know. Okay, but I have to come up with a good example of this. Do I have, what's a good example? Okay, I don't have a good example right now, but like, just as a, will this work? No, it doesn't work. Come on, what's shell? It's because it's -c. Yeah, so I can just like invoke a command from colon. Oh, that didn't work. And so it prints it, but if I tell it to run it on range, it takes the text in Vim as input and dumps the output into the result. So you can use a lot of any Unix filtering, text filtering stuff you have. Anyway, so what are we doing here? This is a Dijkstra. We're running Dijkstra to minimize loss. Okay, cool. Oh yeah, PDF LaTeX is great. So what are the possibilities? We can this should work. Okay, these are the positions in the implicit graph that we're looking at, and we just need to, do I have Dijkstra? Yes. So, what's the source? The source. Slow. And yeah, so there's a little tricky stuff here because there's sort of two sources. There's multiple sources. Why is this? Oh, interesting. What's this grid? Grid. Yep, grid is data. What am I writing? Dot. That's row count, then grid. You have to make sure it's inbounds. And then this is just the new location. And log 0. Come on. No, there's too many possible. This is annoying. So the sources I'm going to specify manually, but the distance I'm going to replace with a sort of manual comparison because there are many possible directions and runs. You can hit the last square with, but the start one is 0, 0, B, 0. And we're going to cut this out. If lock. Oh wait, this is totally wrong because this is, we want to get, these locations are tuples of vector run count. Block 0 is very hacky. P17. 102 is correct for the sample input. Okay, how confident am I? It's fine. It is slowed. Okay, why would this be overly slow? Let's see. I mean, these tuples should hash correctly and such. It is like, that's worrying. Yeah, there's probably a bug. This is n squared Dijkstra, but it still shouldn't be that slow. Okay. Nlock zeros. Oh, it finished. Let's try it. Okay. Huh. That's slower than I expected. That's unfortunate. So in this one, we have to move between 4 and 10 blocks before it can stop at the end. Whew. Very interesting. Okay. Fortunately, this basically still works. So we can't. I kind of want to. I could just delete the letter. Okay, so when do we keep running? 10. So there's some off by. I need to think about one by one here. But at most 3 and at most 10. So yeah, 10. It's fine to move the 10th block. But no, so you always do that. But the thing is that when you turn, why am I doing this? That's right here. If run greater than 4. Is it greater than 4? 1, 2, 3. So when run is 4, that means we've moved 4 blocks. Okay. And when we stop, what did it say here? Or we can stop at the end. So that means that the end condition it's the same. The run count has to be 4, at least 4. Okay. So kind of just check it out. Nope. That's wrong. So let's. No, this should be equal. Wait, why did I? Yeah, this is still equals. This is still equals. 94 is good. We're just gonna run it, and it's slow. Yeah. I've apparently always been too lazy to find a proper nlog in Dijkstra to go in to my codebook for Advent. Anyway, as a for recap, if this is correct, right? The idea is that we're finding the shortest path on a graph of like various possible states we could be in, but the thing is that the states we can be in are not just where we are, but also the information, some information depending on how we got there based on the previous movement. And we store as little information about the previous movement in that state as possible so that Dijkstra can reuse states, basically, right? The whole reason Dijkstra is fast is that once you've found the shortest path to a particular state, the shortest path to get to a particular location with a particular speed or amount of configuration of movement, future ways to get to that, other ways to get to that location, like, aren't going to save you any time. Like, the location data tells you everything you need to know about how you got there for distance measuring purposes. And here, that just has to include both the direction we came in and how many squares we moved in from in that direction. Anyway, unfortunately, this is slow. Let's see. Are there ways to speed this up better than just the nlogin Dijkstra? Is my state too large in any way? It's possible. I mean, it's pretty hard. I think the state is as small as it reasonably can be. What is spending all this time doing? I mean, I guess what you do is you do like some kind of pruning, because if you're, you can use an A*-ish heuristic of the shortest distance to get to the end, ignoring constraints about turning, and then, like, if that constraint, like, you have some way to lower bound your distance from the end, and if you can if you find a very early path to the end, and then you can skip exploring paths that maybe just stay near the beginning and rack up points and don't make any progress or stuff like that. Dang, these are quite slow. It's very unfortunate. Can I PyPy this? Did I ever? I feel like I... Didn't work. Oh. Didn't work because I never set up the method to... get the correct day. Didn't work because of Python installation related stuff. Should I just go work on day 18? Is that cheating? Maybe I should be forced to consider my performance weakness. For all I know, there's a bug still. But at least the way we approached it was very easy to adapt our code from part 1 to part 2. I think the branching factor is just too large, right? Like, what is n here? So, what's the number of vertices in our imaginary graph? It's like 141. Then there's, like, 4 directions you could come in and then roughly 11 runs. That's pretty big. $800,000. 900,000. Squared is, yeah, that's pretty big. That's pretty annoying. Okay. Maybe we should, let's find this. I mean, was it better before? I guess this used to be like about 3 times worse. And then this is like n squared, so it's like 9 times more than like, what is 11 over 3 squared? 121 over 9. Yeah, it's pretty bad. Okay, let's think about how to make this faster and see if we can beat the strategy of just letting the code run. It's the cheapest we could do. We could skip the first 3 steps in every navigation, except that's like kind of annoying to code. That cuts the state space by, I mean, yeah, it does kind of cut the space. State space meaning, does it? I guess it does. We could yeah, I mean, I guess that would also cut like things like we travel off the grid without figuring out that you're too close to be able to turn. So, what would that look like? Yeah, I guess that would, so, yeah, so, okay. It's hard to do this inline, so what we're gonna do is, we're going to just track the direction came in, and we're gonna force ourselves to turn. And this is hard to write. The cost function is hard to write this way, so I'm just gonna sort of embed it here. Nope. 1, 2, 3, 4. We're just gonna do 10. So what I'm gonna do is Dislog, yes. Okay, so what am I doing here? What I'm doing is I'm going to have the cells, the vertices in my imaginary graph be just the location and the direction we came in. And I'm going to require that you must turn at that point. Actually, we can actually reduce this even by one more factor of just either is it vertical or hard. But that's, is that fine? That's fine. That should cut down the state space significantly. So this is, I think, fine. Okay, except it doesn't work. Okay, what's wrong? Oh, new dist. Oh, I didn't. That gives the right answer this quickly. It's faster. How much faster should this be? This should be. Wow, that's really fast. Oh. Well, I'm just gonna type it in. 1237. Alas. Okay. But it's so much faster. So let's see where this bug is. I think this is fine. So the vertices in our measurement graph are just a location and whether you got there horizontally or vertically. And we're gonna say that from that location you have to turn. Oh wait, this is wrong. What? How did I? Oh yeah. Oh, it's funny that that's got the right answer. Yeah, I should have known. I like wasn't actually turning, and I just position was bad. Okay, but this should be a factor of like 44 squared. You know, like 100 times faster than the old code. Is it correct? Nice. We all right. Guess should have thought more. Yeah, so we reduced the state space that of the graph that we were traveling on, and that fixed everything. What is going on? Their colors. Okay, so we have a bunch of colors. Oh god, we have a bunch of colors. But the colors don't matter yet. Instead, for now, we just have to, like, flood fill, you know? Okay, that's fine. But it's gonna spell it. What is this gonna be? It's gonna be like a picture. Why are there colors in my agenda code? That's really something. All right. Okay. We're just gonna start by getting the set of things we dig out. Have a UDLR somewhere. It's right here. I don't know why these aren't vectors. I always want them to be vectors, basically. And they are already row oriented, so that's cool. Yes, U is -1 row. Cool. We're just going to dump them all unceremoniously into a set of all dug terrain things for now. Day 18 was so rude. Says chat. Okay. I will, what's the word? Await the suspenseful second part. Yes, that's what I want. Okay, so now we have a blob of stuff, and we have to figure out where the interior is. That's the bit where it's like, it's kind of, because, what's the best way to do this? Like, the only thing is that I don't know which side is the interior until I, like, look at it. Like, I don't have a point where I'm, like, certain that this is on the interior of the, which is really annoying. So, what's the dumbest thing I can do? I can try every cell adjacent to the center, and if it infinite loops, I will flip it. That's what I'm gonna do. That's sufficiently dumb. This just worked. I guess I'll try it. Nope, it's wrong. Wait, that's not. Oh, oops. I'm doing wrong. That's not the input. Why did it work? 0, 1. Okay, great. It's like probably fine. No, okay, it's not fine. So sad. Let's brute force all the other possibilities. Oh, I see. It wouldn't work because if it hit a scene, one of these should infinite loop. Actually, both of them would. The problem is we need to. So that will still explode. Okay. Or maybe I should try to actually solve the problem. I don't actually understand what it means for. Oh, actually, wait. No, these are small numbers. Oh, I didn't. I'm trying too hard to be lazy, probably. Okay. I'm just curious what the. But actually, wait. I never. What is? Did I even ever actually see the number 62? Am I just crazy? Wait. Why did I think third? Why did I think that was correct? That was never correct. Great. I'm just kind of dumb. Where's the? Oh, I see. I have to be 1-1. Oh, okay. Cool. I just blind guessed. Oh. Ha ha. Ha ha ha. Yeah, I totally thought we were gonna like draw a picture and it'd be like, what's this? Is this, you have to draw it on your terminal and recognize it's the Mona Lisa or something. Instead, okay, what's the correct way to do this? We have to discretize. But it's so annoying because oh, so you just literally ignore the first number. Okay, cool. Cool. All right. Yeah, that's rude. Is rude a fair number word to describe that? I think so. Yeah, that's pretty rude. Cool. So what's the best way to correctly do this discretization? Without any off by one errors and everything. It is a little awkward. I mean, how big are these instructions? Let's see. Also, my code is so bad. My approach is so dumb. I like. Yeah, we can take an extra factor. We're going to do it on 100,000 by 1,000. Okay, so let's talk about discretization, right? So what is that? So we can't. Normally we see here that I sort of basically have this imaginary grid of units, and I'm exploring, neighbors of like each cell that I'm exploring is just a 1 by 1, 1 meter by 1 meter cube, and adjacent cubes you get by adding one in any direction, and then the number of cubes is the area. And that's not good enough to handle this many cubes. So what we do is we write down only, I'm not good at explaining this. We write down only the coordinates we care about, and basically partition the Cartesian plane this way into a relatively small number of rectangles. Okay, I'm gonna, I do. Where did that go? Does it work? It doesn't work. Oh, here it is. So, if we write if you have a grid, and let's say you're drawing this path, always go right 5, then up 4 or something, and then so, each of these cells is like a separate thing. But if you discretize, you're gonna write down, we care about, we're gonna sort of treat all the cells that we don't do anything interesting on as a single unit, and we're gonna explore this whole thing as a single cell during like any graph operations, DFS or whatever. And so this way, this black grid of lines has much smaller dimensions than whatever we're doing here. Okay. And this graph may not have been very useful. I think discretization is the right word you would search for in competitive programming lore, but I could just be wrong. What do we do now? We're going to start by going through this. Wait, so actually they're just completely unrelated. That's cool. That's really fun. 0, 1, 2, 3. And each color is 2 to 7, 16, 8. Okay, and we can't increment all the way here. So what we're going to do here, we are going to those we do start at 0, 0. We're going to write down every coordinate we care about. Is there actually, now that I should check that, these numbers are actually, they're like large numbers. We can't, do you think you can simplify out of this? No, I don't think so. 0, 0, 3, 0, 3, 0, 3. Yeah, okay. You got this, we got this. Do I need both? Or is this just annoying? I think so. is, okay. Just a sanity check that I'm understanding this correctly. Does it go back to 0? Nope, I'm off by 1. 0, 1. Wait, aren't these colored? Yeah. 2, 0, 1, 2, 3, 4, 5, 6, 7. Oh, 7. I see. 7 is the one after slicing at 7. Okay, we not quite complete circuit. So it's a little. Is that concerning? Is this concerning? That's a little odd. I wanted this actually. Is there anything I'm like not understanding? Oh wait, I didn't. Oh, whoops. How did I forget that? Okay, that's better. Yeah, okay, that completes the loop. Cool. So we have a loop, and we need to fill it. So how are we gonna do this? We have to. There's a sense, like I'm discretizing sort of like twice as many coordinates because I want to sort of faithfully capture the fact that I'm tracing a one cell thick line. But in a lot of ways, it would be easier if we could treat this as like a 0 width line and trace it out and then like compute the area inside. But is it? I just feel like there will be some geometric details at the end that are too messy to deal with. So I'm gonna stick with this. Okay, so we now know every interesting coordinate. Now we're going to retrace our path. What do you mean by discretizing? Yeah, so we're going to, let's see if I can do a better job of explaining now. So we're going to take, we're going to write down every coordinate at which we ever turn, more or less, at which we like draw anything. And we know that basically if there's coordinates between lines, like as a very simple, okay, I drew a terrible diagram here. I'm going to draw a new one. Let's say we are just making this like 2, 3, 4, 5, like it's a 4 by 4, okay, 5 by 5, 4 by 4 by, okay, so we're going to do, how does this say? This square is 4 cells, 4 cells, like traveling 4, 4, 4, 4, and you get a 5 by 5 square. And normally you'd have to sort of fill this by like going 1, 2, 3, 4, 5, 6, 7, 8, 9. Like you have to explore all 9 cells. But we're going to first do a sweep where we write down the fact that, oh, we only care about these coordinates, like these black lines, where we did anything. And any region bounded by these black lines, it's all the same, like it's all filled. And we're going to be able, that way we'll explore on this black line delimited grid. We can search it, and that grid is relatively small. And each cell of the grid has a different area, but we just take that into account at the very end. Okay. Let's see, what are we doing now? Same stuff. Now we have to, okay. So, and whenever we put a thing in set, we're going to, this is the annoying part. Okay, so yeah, maybe this is also called coordinate compression. Maybe, I don't know where I got this name discretization in my head from. Maybe I'm just making this up. But yeah, I think it's like closely related to, like, coordinate compression sounds plausibly like a different, the same, a different name for this idea that I have in my head. Okay. The question now is, what do we... 600,000? That's fine. Okay, so what is the dumbest thing we can do here? No, we do, okay. It's really bad. R inverse. Okay. So now, just want to dump. Let's see. Okay. So. We're going to fill in every cell between these two. So, no, what? That's not even correct. Oh, that's not, okay, so, ooh, okay, so we want to, so I'm working with two coordinate systems now. So one is the system of black lines, and one is this where basically the black lines are given by these two lists of coordinates, and there's only like 1,000 of them, whereas the big coordinates are what like Kerr is tracing out. So we have to convert back and forth between them, and yeah, so this single square bounded by the black lines at Rn and Cm0, that is the starting black square. How dumb can we be? So, no, it's okay. So, now that I think about it, like, yeah, like, where'd I get, okay, I don't know the names of things, I think. I don't know what names of these, like, competitive programming techniques are. That's just, I have vague memories of how they work. What? That's totally wrong. Yes. C inverse. Okay. You're gonna travel from. Oh god, this code is so bad. Write that before I forget it. There's a travel between them. Is there a signum or something? Oh, actually, that's pretty funny. The direction is the same as this direction, so. Okay. And this stuff is actually the same. Except I don't know which direction this is. Okay. And then the tricky part is here. So we have to sum this. So area 0, 4. Compressed location. Find the distance to the next black line and add it. Go 18. Let's see that. Okay, didn't work at all. Cur, it's called cur. Wait, what is slot? Doesn't exist. And that's correct. Okay, I picked the wrong direction. I should. There's no way I don't need this much recursion. Force it until we get an answer. Okay, more. Wait, this is way too large. I'm stupid. I'm dumb. It's not enough. Wait, let me think about what my it's not. I mean, okay. I guess in this case, it's probably a bug where I'm like not. Oh, I see. Maybe I'm not filling in the last guy or something. I do that. And I know for the sample it was. Yeah. This should work for one of the corners. Maybe I should look at the input and figure out where the which one have I not tried? What's the better way to do this? It's so annoying to do it correctly. Which one have I not tried? Okay. I think there's still a. Is it true that yeah, okay. Is my there's no way this is okay. I have some bugs. Yeah, bugs. I mean, it worked on the sample though, which is actually pretty impressive in this case. This is actually the right number, right? Yeah. Cool. Okay, so why is it not working? I mean, if you just hold on, I guess to sort of sanity check that. Oh wait, what am I doing? Wait, this I have to go from here. That's how did that work? It's not 1-1 anymore. It's this relative to this guy. So that's probably just way outside the thing. Okay. right, whatever. Nice. Okay. What a disgusting solution. I'd be too embarrassed to post this anywhere else, but since it's live, you have to see it. Oh, okay. Thank you, chat. All right. I see. Oh yeah, right. You can do that. I totally forgot. We literally learned this a few days ago on Heaven of Code. Oh well, so much for that. Yeah, everybody else. Yeah, you can just use. I mean, it's so annoying to like. You can use like the formula with it's like picks. No, you do. What do you do? You just like follow do the vector math and like it's fine. But okay. Instead, we did the hard way, and I learned that I'm super washed up. Haha. All right. There's so much going on here. So you have a workflow. The nameless rules. So it's like a sort of switch condition. So okay, so oh man. And this is not even valid JSON. What are these objects? Parts. They are parts. Data. Are they all? Are they all in order? Yes, okay. So I'm just going to... Well, no, that's not... Okay. Okay. Every part is just 4 numbers. I like can't be bothered to do anything else. Okay, so how do we parse this thing? So label cases, I'll call them cases dot. I'm gonna cut off the brace split by comma. And then so for case in case, oh man, case keyword, cast in cases, if colon. It's called outcome. No, what's it called? Whatever. Okay, cast. We're gonna do art. We should eval this. Yes, we're gonna do that. Yeah, that's the easiest way. Cool. So Excellent. Label out cases. Oh no, actually, no, this is a dictionary. This is a dictionary. Cool. Oh, these should be eval too, actually. That's pretty funny. Okay, I'm gonna do so illegal. All right, redoing it though. 4 parts. Exec. No, this doesn't work. Okay. Oh no, it's fine. It'll work. Piece in. I am displaying an extraordinary amount of trust in the admin of code input pipeline right now. Which rule do we start with? In, okay. Cur is in. For while cur is not in. Just in case. Case is for if accepted, x plus oh, I can't use s because it's taken. YOLOing so hard. Nope, didn't work. I see exec. Okay, this is fine. Oh wait. Scoping. Oh, come on. What is this? What is this? Oh, oops. I didn't even test. It's too confident. Oh, no. I see. I see how it is. 1 to 4,000. Guess we're not evaling anymore. What's the right way to do this? I guess it's like we don't even need to discretize. Like it's kind of this very similar idea where we don't want to try every rating combination one by one. We want to notice that when a rule, like if no rule is distinguished between like x equals 44 and 45, then like those two ratings should just like send them through all rules together. Okay, so it's not that actually every rule is just I think this should be fine. Okay, so what we're gonna do is you're gonna have this like we're gonna have a parallelepiped thing. It's 4. What is it? 4 dimensions. I don't know what it's hyper. I just call it a hyper rectangle, but it's bounded by so we have a minimum and maximum for each of the 4 ratings, and that represents like a solid block in hyperspace of 4 ratings, and we're gonna pass that through all the rules. When a rule breaks it up, we're gonna keep the things on both sides of the rule together as a sub parallel pivot, so that we don't break things into too many cases. Okay, so it's not very easy to write. Okay, so is it a class time? I think, sure. So what is this thing? Should I use data class? This data. No, I'm not gonna do it. No, it's fine. Same way to has to be a list. Okay, so bounds equals, and we have to. We're gonna use half open intervals as we do. It's just that times 4. I mean, man, do I really want to make a class of this? No, this is fine. Okay, so def split bound rule. What is it going to return? List bounds. Okay. Does it say what the like? Well, actually, they're always inequalities. Well, that's easy. Is that easy? I actually had in my head that like there would be like equal signs in any of the rules, and you'd have to split the hyperrectangle into like a middle slice that goes into one rule and then halves in the other. But that's not even, it's nowhere near that. Okay, so the main thing we do want to do, so var inec bound I don't think this will work. So okay, so if bound is true, no, so we do want this because it could be empty. Bounds for if it's just thinking very carefully about everything here, so and not get any off by ones. It's the lowest. No, just that. Wait. No, I think I'm not fence posting wrong. if it's less than this. No, that's fine. Less than bound. We are counting. Okay, no, bound is correct place to cut here. This one's the part. Ooh, very tricky. So many off by ones. No, it's assertion. And I have to be very, very careful here. So first, these are flipped. So this becomes less than equal to. And the cut, no, it's just, I just think of it as bound plus 1, I think. And then it's kind of symmetric. Because testing x greater than equal to 3 is, yeah, I want everything to be greater than equals to. Greater than equals to is the way to handle these half-open intervals. Yes. So split here. Does this look good? Yeah, I think this is fine. Okay, so bounds is rule label. I can ignore this now. Why is it commented or is it indented? It's fine. It doesn't matter. I know. I see. No, this is just going to return the number of things that get accepted. You take a single bounce at a time. And we made sure that, I think product is my helper, but we made sure, so each of these bounds represents a hyper rectangle in 4D space of parts, of possible part configurations, right? Bounded by, this is a list of 4 tuples. Each thing is a half open interval of a particular coordinate. I always use half open intervals because subtracting high from low gives you the right length, and intersecting them and all kinds of things. There's like, this is great paper by either surprisingly or unsurprisingly Dijkstra, again, arguing for why half open intervals are super good. And I think they are. So if we accept them, we accept everything in the hyper rectangle, hypercube. If we hyper parallelepiped, hyper rectangle, whatever. If we don't reject 0, otherwise. So for rule in a good rule sod rule label. Do you do any other coding competitions? Ask chat. Like, not really anymore. I used to do Google Code Jam, was like my one thing a year, and then they stopped. It was kind of just because it's the biggest thing where everybody else was doing, and it's fun to do things when other people are doing them. Yeah, I don't know. There's tons of Codeforces competitions and stuff that I used to do maybe one a year, and now I think it's like even less than that. But yeah, the short answer is no, I don't really do other coding competitions at this point. What am I doing here? Part no, this is case. Cases is this. If T's F is, what do I call it? Split condition for T and TS. Oh, I see. Okay. It's a little inelegant to do it this way. What do I do now? Okay, I do. Okay, I think none is better. That's... Nah, it's fine. It's fine. Outcome, T outcome. This is so... It's getting pretty ugly, but I think it's fine. Okay, assertion error. Oh wait, this is not right. It's not all. This is inec. Uh-oh, why are we inting that? Oh, true. Yeah, this is true here. We can just do that. We should test it. What? Same. How do we have the same answer for the... That's pretty bad. What is this number? That's no good at all. Ha ha ha. Yeah, 14001 is what I want. Did I? Wait, this is the same. So it's possible my answer is correct. I'm still gonna test it. What? It's not copying. I'm bad. That's the right answer for the sample. Yay. And that is 5 problems. How long have we been streaming? Oh wow, it's 2 hours. Okay. 5 problems, 2 hours. Good deal of tangents, more so than average. But we made it. Thanks, chat. I will see you in a few more days. Have a good holiday season. Thank you for watching.